yet again. Today we're going to be talking about the Hermes simulation in the Monte Carlo as far as the stock prices. So in my last video, I showed you that I used an app in order to create the price tracker of Hermes. And that was actually using the European market price. So if I'm able to look at this, I'm able to see that the European closing price is going to be £2,000 and 98 dollars. So if I was able to use that, I would have to convert that, and this is pretty much roughly what that would be. What the crazy part is, and I guess I haven't really thought about this, is the price difference of buying a stock in Europe versus buying a stock in the US. I know that this is a big thing in Forex, which is, I know, very different concept than, buying from different exchanges. But it's kind of interesting how the pricing or the closing price is different in the US than it is in Europe. It's definitely worth more in the US than it is in Europe, okay? So it says here that the stock exchange, Europe Next, Paris Exchange in Europe is on a less regulated over-the-counter market in the U.S. And these are some of the key considerations. And to be quite honest with you, this has to do a lot with just, political things, right? What I do like about it is the fact that Hermes went through some sort of legal proceeding about whatever or not that they can like have quota bags or restriction on their bags, and they actually want it. So I think it's very interesting to see value-wise how that would maybe determine why they would say, hey, if you guys say that we can't do this, we're just going to pull from the U.S. I wonder if they pull from the U.S. or pull their source from the U.S., do they also pull their stock from the U.S.? That would be kind of interesting concept I guess I can look into. But anyway, so the Monte Carlo simulation, I did this in Google Colapse, and I have my notes here, and basically I do the same thing I always do, and that is to have it break it down, and then for me to look to see what these things actually mean, like the parts of what these things mean. So let's use E, which is the exponent of this, which is not included in here. And again, that's that log. That's the natural log of that. So the base natural log. This is expected returns in the annual volatility of a asset, which is the standard deviation of the return. See, we're using our standard deviation. Then you have T here. I think T is delta, right? Let's see. I also have some examples here, and this is more for me. I don't think you actually, it's delta. You don't probably need to know this to use the Monte Carlo stock. In fact, you could probably just plug in numbers and be fine. I myself always like to take it a step above. Next, I want to know what in simulation is. I'm like, what does that mean? That is the aggregated results. And steps 2 and 3, which are these right here, you gotta set up parameters, all this other stuff right here, are simulated over a trial period. So that is what simulation is, okay? So basically, I have it broken up into these keys so that I can break down what they mean. This is pretty good. Tomorrow price will equal today price times 1 plus, is that sigma? No, I'm trying to see what all these times sigma, I think that's right. Yep, wait, nope. Sigma is this. That little symbol there, I need to add in there because I would like to know. It's not the rate, it's the chain, it's the drift. But I would like to know what that actually means as far as the symbol goes. There's beta, delta, and then alpha. So it's beta, delta, and alpha. So it's probably one of them. That's probably alpha. Anyway, not to confuse you guys any longer, you can just basically plug in the numbers and figure out what it actually does for you and how you can use it. It basically tells you a range of forecast pricing. In this example, the mean here is right there at 2050 range. So the high possibility is at this particular range here. But as you can see, it's everything is playing in that 2000 range. And it's very unlikely that it will go to 3,000 or it will go to, let's say 1,000, less than 1,000, less than 2,000, or 1,000 or 600 or or less than 30%. So maybe I should start for my app. I should actually look for 20% or 10% change, so on. But it's a closing price versus the incremental hour by hour, minute by minute price that high frequency traders would use. But anyway, I just thought it was an interesting way of learning the Monte Carlo simulation and what Monte Carlo is. I also have another one here, and this is a mathematical process of possible events in a bunch of states, and I can't say it. Morcovio, y'all know what I mean. I thought this was also pretty interesting. But it's simple. I think this is the most simplest thing ever because it's basically updating the states as new changes are integrated in. So the probability of moving to the next state depends only on the current state. So it is a memoryless, meaning that the change of future evolutions is independent of how it arrived at the present time. And the present history doesn't matter, only the current condition. Thought that was interesting. And I think I have LLM shape. So what is shape? I hear a lot about shape, and shape is basically just a mathematical process. It's a mathematical operation. It doesn't actually have a shape. There's no real shape for LLMs. That's pretty much it. That's what I'm working on. If you guys have any questions or have some new projects, I would love to hear them. Until then, bye.